This video tutorial is an introduction to XAML. You'll learn some of the core concepts of XAML using Microsoft Expression Blend. Additionally, you'll learn some of the benefits of XAML as it relates to the designer-developer Silverlight workflow. XAML, pronounced XAML, is a case-sensitive text and tag-based markup language like HTML or XML, and is in fact a descendant of XML with a few distinct and important differences. It was created by Microsoft and used as the language behind the visual presentation in a Silverlight or WPF application. The acronym originally stood for Extensible Avalon Markup Language, Avalon being the code name for the Windows Presentation Foundation, which is a graphical subsystem for rendering user interfaces in Windows-based applications. Although XAML is also used by the Windows Workflow Foundation, it is mostly known for its role in declaring and initializing objects in Silverlight and WPF applications, and with more recent versions of XAML, mapping events to object functions to provide basic interactivity. Now let me restate that because it's a very important key in understanding the role of XAML. XAML is used to declare and initialize objects in Silverlight and WPF applications, and to allow for basic interactivity. You can see the role that XAML plays more clearly by viewing this Silverlight architecture diagram. As you can see here, Silverlight applications are comprised of two main subsystems. The .NET for Silverlight subsystem, where you have things like data access objects, the Windows Presentation Foundation layer, and the Windows Communication Foundation layer. And you also have the Presentation Core subsystem, where you have things like the User Interface Core for vector and text-based drawing, keyboard and mouse input, and things like digital rights management or support for various types of media. The role of XAML is to serve as the primary point of interaction between these two subsystems. For example, we can interact with this presentation framework by using XAML to specify presentation details. Or we can bind data objects in the .NET framework with presentation objects in the Presentation Core. XAML elements, which are represented by tags, map directly to the object instances in these subsystems, while XAML attributes map to the properties and events on those objects. If you're familiar with the .NET framework, you'll be very familiar with the elements used in XAML as they map one-to-one with a portion of the .NET framework that is compatible with Silverlight. The beauty of XAML is threefold. First, it allows you to separate designer code from core logic, and second, it helps to reduce or eliminate coding since it is a much more compact language than, say, C# or Visual Basic .NET, and because it is, by its very nature, much easier to dynamically manage XAML code than traditional programming languages. And last but not least, it helps designers easily share design elements since XAML is text-based and can be copied from project to project without compiling. Like with many tools that support HTML development, such as Microsoft Expression Web, XAML elements can be edited visually or with a text editor. And with Microsoft Expression Blend, you can seamlessly switch back and forth between the visual and text editing of XAML code. Once you have declared your XAML elements, you can then use a separate code behind file to respond to events and manipulate the objects that you declared in XAML. In fact, the most recent editions of XAML and Microsoft Expression Blend allow you to do some of this without even having to reach for the code behind file at all. This is made possible through new behaviors that you can map to your objects and which act on specific events such as a mouse click. So let's have a closer look at XAML using Microsoft Expression Blend. Here I've got a Silverlight application already loaded. And I'm looking at my blank artboard, which is comprised of a layout root living inside a user control. This is the default container that is used when you create a new Silverlight application. Have a closer look at the Objects and Timeline panel, as this panel maps very closely to the organization of your XAML code. Let's start by modifying the layout root to be a canvas type, as the default type is a grid type. Simply right-click on Layout Root and then choose Change Layout Type and then Canvas. Now let's draw an ellipse on this canvas. While drawing this ellipse, I held down the Shift key to ensure that this ellipse is a perfect circle. Now, as you can see in the Objects and Timeline panel, I have an ellipse that is contained inside a layout root. Now let's have a look at the XAML code. With Microsoft Expression Blend, you can view the XAML code behind this drawing. Simply click this button here that looks like a less than and a greater than sign connected together. The split view allows you to see the mapping between the objects that you create on your artboard and the XAML code. For example, here in the code is the ellipse that we drew on our canvas. As you can see here, it's a white ellipse with a black stroke, and it has a height of 136 pixels and a width of 136 pixels. The ellipse is known as the XAML element. This refers to the name of the object that is created behind the scenes. It is also referred to as the object tag. To the right of the object tag, you'll find the object's attributes or properties. In this particular format, the attributes are followed by an equal sign and then in quotes the value for the attribute. So here we have a white fill, a black stroke, and your height and width attributes. In some cases, you'll notice attributes that are separated with a dot. For example, we have a canvas.left attribute. This is called an attached property. Left is an attached property of canvas that is available to the ellipse. The reason it's called an attached property is because the property itself is actually owned by the canvas, but it is accessible to the ellipse. It is the canvas that reads the value of this attached property in order to know how to render this particular ellipse. But it is the ellipse itself that is in charge of the value of this attached property. Keep this in mind as you'll find that attached properties are used quite extensively throughout the Silverlight framework. The important thing to note here is the relationship between the ellipse and the canvas. This is what's called a parent-child relationship. You can see the relationship in the Objects and Timeline panel, where the ellipse is a child object of the layout root, which is a canvas type. Likewise, in the XAML code, you can see the relationship by the fact that the ellipse is nested within the canvas object and is indented. Here you can see the opening tag for the canvas element and its corresponding closing tag. When objects are declared this way, it's known as object element syntax. But as you can see here with the ellipse object, when it is declared in this fashion, this is known as attribute syntax, where the entire object is defined in one line, simply by defining the type of the object and all of its properties. At the end of the object declaration, you'll find the corresponding / and closing angle bracket. But the beauty of XAML and Microsoft Expression Blend is the reflective nature between the XAML code and the objects on the artboard. For example, I can change the fill to a different color. Let's call it black, for example. As you can see, not only did the ellipse automatically change as a result of changing the XAML code, but the Properties window also reflected that change correspondingly. Similarly, we can change the properties of the ellipse through the Properties panel, and that change is reflected on the artboard and in the XAML code. In this case, since it's not a specific color, the color code has been inserted. I can also take my object and move it around, and you'll see the corresponding change in the XAML code with the canvas left and canvas top attributes. Let's have another look at that. Also keep an eye on the Properties panel, where you'll see the canvas left and canvas top changing as well. So it doesn't really matter whether I modify my XAML code manually through text editing, or by modifying the objects on my artboard, or through the Properties panel. It's all kept seamlessly in sync. Now let's draw another object over this circle. For example, let's take a rectangle and draw that rectangle directly over the ellipse. And let's change its color. So now we have a white rectangle over our colored ellipse. As you can see in our XAML code, the rectangle appears after the ellipse. The order in which the objects appear in the XAML code is the order in which they're drawn. Similarly, the order is the same in the Objects and Timeline panel. If you read the Objects and Timeline panel from top down, that is the order in which the objects are drawn. This is the reverse order that you might be used to if you're using layers in something like Photoshop. Of course, in the Objects and Timeline panel, you can reverse the order that is displayed by clicking this Arrange by Z Order button. Now suppose that we want to bring that ellipse so that it's on top of the rectangle. Well, it's very easy to do in XAML code because we can simply cut and paste that line of XAML code and move it above the ellipse. And now you see the ellipse is on top of the rectangle. We can do the same thing by dragging the object in the Objects and Timeline panel. For example, I'll drag the ellipse back above the rectangle, which will put it underneath the rectangle on the artboard. Since the ellipse is currently selected, you can still see its outline, but as soon as I select the rectangle, the ellipse disappears. Now let's move the rectangle back behind the ellipse. You'll also notice that as I select objects in the Objects and Timeline panel, the corresponding XAML code is automatically selected. The same thing is true if I select those objects on the artboard. Now let's say that I don't have the XAML code currently in view. For example, we're in the Design view. By selecting any particular object on the artboard, I can right-click on it and then choose View XAML. And that will highlight the line that represents that particular object in the XAML code. Now let's have a closer look at the definition of the rectangle in the XAML code. We have a fill, a stroke, a height, width, canvas left, and canvas top. But let's say that we wanted to add rounded corners to that rectangle. Since our rectangle is already selected, we can simply drag these handles to make rounded corners. What you'll notice is immediately the XAML code is augmented with the radius X and radius Y to represent the rounded corners. These particular attributes are not initially present in the XAML code because Microsoft Expression Blend is very good at hiding attributes which are in their default state. So for example, if we don't have rounded corners, there's no need to enter that code in the XAML code. So for example, if we don't have a need for rounded corners, those attributes don't need to be present in the XAML code. This particular behavior is very useful at keeping your XAML code looking as clean as possible and without cluttering it with elements that aren't relevant to your particular layout. Just as I had added rounded corners to this rectangle, I can similarly highlight the XAML code and delete them. And you'll see immediately that the rounded corners are removed and I'm back to a square-cornered rectangle. Now we're going to look at another important concept called grouping. So let me take my particular drawing here and modify it a little bit so that it looks like we're making a video player. I'm going to take my rectangle, add my rounded corners in, change its background color, and then this circle is going to be representing the buttons for my control for the player. Now I'm going to duplicate that button by holding down the Alt key and then dragging that button to the right and doing that 3 more times. Actually, let's keep it at 4 buttons. And now I'm going to draw our player window just above the buttons. So now that we have our player buttons and our player window, one of the issues that you'll notice is that the background isn't connected with the player objects. So how do I group these objects together? Well, you simply want to select all the objects in your player and then right-click and then choose Group Into Canvas. And now in your XAML code, what you'll notice is that a new canvas was added underneath our original canvas. This new canvas contains all of the elements of the player, our rectangles, the outer rectangle, the inner rectangle, and the player buttons. Now let's talk about naming conventions for a moment. It's very important to establish a proper naming convention, especially if designers are working with developers. In order for a developer to access these particular objects in the code behind file, these objects must be named. For example, this canvas object, which represents our video player, should probably be renamed to something like video player. So we can do that by clicking once on this canvas object to select it, and then clicking again on the word canvas, one time, and then it becomes highlighted, and at this point you can rename it. Another way to do the same thing is to right-click on that and then choose Rename. Now that we've named our video player, our developer can access this particular video player in the code behind file. The same name that you see here is also in the Properties panel, right here. In fact, we could have named it by typing in the name up in the Properties panel. So now going back to my XAML code, I can see that my video player name has been added to my code. Now before we have a look at this code in Microsoft Visual Studio, let's set up a quick animation for this video player. I've already got my video player selected, and I'm going to drag the corner and then rotate it 90 degrees. Now I need to set up a storyboard for the animation. The best way to do that is to go into the Window menu and then choose the Animation Workspace. Now I'm going to hide the XAML code for a moment here. And let's create a new storyboard. You do that by clicking this plus button here under the Objects and Timeline panel. Let's call this storyboard Rotate Player. Next, let's drag the playhead to the right to approximately the 2-second mark. And now let's define the position that we want this player to be in after the 2 seconds of animation. And now let's confirm that the animation plays correctly by pressing the play button. So now we've defined the keyframes that we need for this animation, as you see here, and we're done with our animation storyboard, so we can close it at this time. And you'll see the video player snaps back to its original position. Now let's have a look at the XAML code. You won't see much of a change in the original XAML code that we had developed, except you'll see this render transform code being added. This was because of the original rotation that we made to our video player prior to setting up the animation. But what you will notice further up in the XAML code, completely separate from our canvas, is our storyboard resource. This defines the animation for our video player. This particular animation can be directly targeted by our code behind file or even through a behavior that fires off the animation. Let's set up a quick behavior. Going back to our design view, let's go to our Assets panel in Behaviors and then drag this Control Storyboard action onto our video player. And over in the Properties panel, we'll see that the left mouse button event is already assigned to the video player, but we can choose a different event such as mouse enter, and we can assign this particular event to our Rotate Player storyboard. Now let's run this application very quickly. Now as you can see here, as I mouse over my video player, it fires off the animation without having written any code. Now let's switch back to our design workspace. As I mentioned earlier, one of the beauties of working with XAML is that it separates the code from the design. So for example, let's say that a developer wanted to modify some of the behavior of our application using Microsoft Visual Studio. To open up Visual Studio with the exact same application, let's first go ahead and save our solution. And then to go straight to the main page.xaml when we open up that solution, just right-click on the main page.xaml, which represents this artboard and objects that we've created here. So right-click on it and then choose Edit in Visual Studio. What you'll see here is that we're brought straight to our XAML code that we had seen in Microsoft Expression Blend. You see the same storyboard resources and the same objects that we had defined. Now it might not be obvious, but if you click and drag this little splitter right here, and then choose Resume Loading the Designer, we can see the design that we had created in Microsoft Expression Blend. Now let's zoom out just a little bit. Now even though we're using Microsoft Visual Studio, we see the rendered object just as we saw it before, and we can even make changes to the XAML code and have it reflected in the view that you see below. For example, let's change the fill of our rectangle to a different color. You'll even notice that as I start typing colors, the available color choices pop up automatically. So now we've changed our video player color to a black background. Let's go ahead and save our solution and then switch back over to Microsoft Expression Blend. As you can see here, Expression Blend notices that our project has changed externally and it's asking us for confirmation to reload this solution. So double-clicking back on our main page.xaml, we can see that our video player has been modified with the new background color. And in the corresponding XAML code, we can see the same changes to the fill color that we made in Visual Studio. Everything we can do in XAML, we can also do in C# or VisualBasic.NET code. But XAML is a more efficient way to create initialized objects that can be later referenced in your C# or VisualBasic.NET code, where more advanced operations and logic are required. Thanks for watching, and I'll see you next time.